How many people are here? Oh, it's not showing me the whole thing. Quite a few. Okay. Hold on. How do I see 20 participant? All right, it's at the bottom. Amazing. We'll give it a few more minutes for the rest of you guys to join. Yeah. Mhm. Can you guys check? I'm sure you have a group or something if the rest of the class is going to join soon, right? And then report back. I'm ready to start if more people are not joining. They're 21 now. I'll bring the notes out here. Share my screen. Oh, no, not this one. Still the one. Share. Oh, should be able to see the whole thing.
Assalamu alaikum. Ramzan
Yes.
Mubarak.
All right. Shall we start or should we give it a few more minutes? All right. Okay. So, good day, everyone. Hopefully you are enjoying the wonderful weather we have right now. Um, I was waiting for the university to send us an email to make it online, which they did eventually, and I put it up. So thank you for being here. Hopefully you all had a fantastic long weekend, some time to finish up the labs and do some readings. You saw, hopefully, I put an announcement up there, so you should have your grades for your quizzes up there as well. And today we're going to go over RSVP. And after this session, you'll have another lab that's due. And then finally, next week on Monday, you have your, I'm mistaken, right? Next week on Monday, you have your final exam. It'll be in class in person, probably around 2 hours, hour and a half or two. And then you have your lab exam, which is on the 25th, right? And I will talk about the exam after, towards the end of the class. Okay? So, this is going to be difficult because I can't see the chat when I share my screen. So, can you guys just, share, as I talk through, if you have questions, raise your hand or put something in the chat. Feel free to unmute yourself and talk so I can see what's happening here. Layout. Let me choose the layout. Background, say by say. Sure. No, content only, that's fine. Give me a second. Elvis, I like how Microsoft Team does it now. Only because I'm so used to it more. Oh, well, okay. So last time before I finished, we were talking about MPLS TE, which is the tunnel engineering. And what were you referring there here? Sorry, I'm just going to move the view here. Okay. And what we were talking about is why there is a need for tunnel engineering. If you remember, we talked about the fish problem, right? But what we talked about earlier is if you have a network topology and you're running a routing protocol on it, generally the routing protocol will pick up the best route. And once it does, it will use that all the time. It will not move towards using your other path, which might be underutilized. So tunnel engineering is a method of setting up few more setting up a condition where you can use other links as well. And it sits on top of your routing protocol. So it works as a forwarding, like it injects routes to the next hop, right? And that's how it works. So the way a tunnel engineering structure is basically this is the method of how it runs. So number one, there's a TE control. Obviously, T stands for tunnel engineering, right? And in this control, what we do is we look at, okay, let's look at the routing protocol, right? What is the topology table? How can I go from one source to the destination, right? And let's show me all the paths. And then I talked about this. There are some parameters you can configure on each of the tunnel engineering in each of the router. So it actually checks all those attributes. Like, okay, what are the different attributes? And these attributes are could be anything. These are manually configured. We configure them. Could be cost, bandwidth, among other things. Okay. Then when you actually use tunnel engineering, it goes through something called a discovery phase, where it discovers the entire source to destination and finds out, okay, I have to go from this location to that location, and I need to check all the attributes and all the links that are available. Then based on all this information, it computes the best path on its requirement, right? And there's a protocol that goes through it, and it takes into consideration all the attributes you have to put in. Right. So if you look at it, I actually have it step by step, what's happening, how does it go through, compute the path. Then once the path is computed, it finds the best one, right? Whichever satisfies it at that time. It establishes a tunnel from one source to the destination. And that tunnel will start forwarding the traffic for that specific condition. The tunnels are one way, meaning it's not how traffic is bidirectional. The tunnels are established only one way. So traffic returning will need to establish a separate tunnel because this is for forwarding the traffic to one end, and that return traffic will have to creates its own. Every downstream router executes admission control, meaning it's like you have something called the available bandwidth configured. It's like, hey, I need to use this much data. Do I have enough? Because each router can support a certain amount of tunnels, right? It's manually configured. So once that limit is reached, generally the algorithm is like, okay, this device is busy with all the I need to find another path. And that's how you use multiple links. Okay. After the establishment of the tunnel, some T parameters may change. So let's say I assign the bandwidth value of 10, and the tunnel that is formed is using 5 of it. So what it does is now the new available bandwidth on that device will change to 5, meaning next tunnel requirement, whoever comes in will need to compute based on the available bandwidth. Once the first tunnel is complete, it strips down the tunnel completely. The available bandwidth will go up by that value. So if I used 5 and available is 5, then 5 plus 5, it becomes 10. Tunnel labels and related information are fed to the data using FIP. So the labels are sent based on. So basically, we manipulate MPLS labels, right? But we want to use layer 2. And we push those labels out for that specific source and specific destination. So now, instead of using your MPLS regular label, we inject these labels with a better priority so the traffic goes in a certain path. All right. Okay, so let's look at this is going to be tough to explain, but sure. Let's go through it. So looking at the top, you have PE1, P1, P2, and PE. PE2. By the way, you guys can all hear me okay? You can see me okay? You can see the screen, most importantly. Yeah, or actually, if nobody can hear me say something. Okay, I got one thumbs up. Anything? Okay. So now in this scenario, you've got so you've got PE1 to PE2, and you have your P1 and P2 in the middle. So when a path is required, right, we send a specific request across. We send our session ID, the P hop. That means, okay, this is my first penultimate hopping, right? So P hop 1, P hop 2, P hop 3, label request, flow spec, session attribute, and sender description. So we send all this information to the end destination. And then based on that, the end destination starts replying back, right? And we inject that in the MPLS table. This is what I was referring to earlier. So if you look at the message here in the bottom, right? So we're going from PE1 to P1, P2, PE2, and then the end device, right? This is the request by PE1 that came in. The second one would be ER2. So this ER1, ER2, ER3 is the router one, this one, router 2, and this is the router 3 in terms of this PE, right? I forgot what E stands for. Anyway, and this N hop, number of hops, right? So this is N pop 3 is PE3, is this one, and then pop 1 is this one, right? So when I request a tunnel coming across, because it's destination based, whatever destination is here, we'll inject a label here, 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 here for this specific reason. And that's what I'm trying to show you here, right? So the label for PE2 would be 40, 50, 30. So when the traffic goes out to that destination, I'll use label 30. It will be swap 30 to 50, 50 to 40, and then penultimate hop popping. Okay, that's how it works. All right, so let's talk about this very quickly. So when we talk about tunnel engineering, there are three things. I think I discussed this very quickly, right? So there are three things we assign on the devices, right? What do we assign? We assign administrative weight. This is just a priority. Higher weight is preferred, lower is not. I think it might be the other way around. We'll check it out very quickly. And then the total available bandwidth. Because what you don't want to do is give 100% bandwidth for that specific one. You want to keep some. Because in any design code, generally it's not static. You don't have a path that's completely redundant and one path is completely dormant. Generally, some traffic is always there. It's not optimized. So by assigning available bandwidth, let's say associate is like, you know what, tunnel engineering can use up to 50% of the bandwidth. I'll put a value there. And then we talked about link attributes, right? These are different attributes that we configure to identify certain condition about the link. Like, hey, this is a fiber link, this is an Ethernet link, this is a Wi-Fi link. Those are all values we can configure. Okay. Now, administrative weight is the TE link cost, the metric that we give. By default, TE link cost is the same as IGP cost. So if you're running OSPF, you're running EIGRP, depending on what, that's the metric it uses, right? So OSPF has own, that's the weight it'll use. But you can configure it, you can change it. T tunnel metric calculation is based on TE metric. So basically the tunnel engineering metric, whatever it is. Okay. How do you configure this? You can change the weight, obviously, right? And in order to change the weight, this is the configuration you put in the router. You put the administrative weight and you put the weight, whatever value you want. So in this scenario, what we're showing is by default, the value is 5, but when you put this command in, and I put 2, the value will change to 2. Available bandwidth. So available bandwidth means how much bandwidth is available to any traffic that's going there. So you have something called reservable bandwidth, meaning this is how much is allocated for a tunnel. And as we take more and more value out of it, less information is available. In this scenario, if you look here, right, from R1 all the way to R7, actually just have to look here in these two devices. So between these two, right now, sorry, so in this scenario, all the bandwidths available, every single link is 10 megabits per second. Now, when you get the first request coming in, is like, hey, I want to go from R1 to R5, right here. And the bandwidth I need is 8 megabits per second. So when you get this, you're like, okay, I want to go from R1 to R5. What's the best path to it based on weight and everything? So you have got two paths here. You've got one, two, three, four, and then, or you can go this, right? Okay, so I've got two different paths. This path is better. Second step, you check, do I have enough bandwidth? So looking here, right, if everything is 10, then it makes sense to go this route. Like, okay, I take this path going there. Now, when I get a second request here, sorry, hold on, one, two, three. Okay, yeah. So when I take this path, sorry, right, what has happened? This was available bandwidth that I has configured as 10, and I used 8. So from this link to this link, all of a sudden, now my bandwidth available is 2. R2 to R5 would be the second one. The available bandwidth would become 2. So 10 minus 8 becomes 2. So when the next request comes in and it's like, hey, I want to go to a destination. Here I'm going to R7. It's like, and my bandwidth request is 5. First thing I look is like, okay, what's the optimal path? It's like, oh, this is the optimal path. Okay, do I have enough bandwidth? I need 5. What's available here? 2. Oh, I can't go there. So this path automatically is a no-go. So it's like, what's the next path? This one? Do I have 5 megabits? Oh yeah, there's 5 here, 5, 5. This was 10. The new available bandwidth between R2 and R3 to the destination would be 5 minus, sorry, 10 minus 5. So it'll be 5 available bandwidth. Very simple. Okay, how do you configure this? Here you go, right? Bandwidth total reservable, how much you will allocate on it. So this is manual work you have to go in and configure. So every time you configure a different link, you put it in. So if it's a 10 gig, you can put 10, 5 gigs of reservable, 1 gig of reservable. It really depends on how you're doing this configuration. And then tunnel bandwidth configuration, this is how you put this information in here. Pretty straightforward, nothing specific, right? A numbered loopback, tunnel mode traffic engineer, destination address, tunnel MPS traffic path option, you put all this value in, and then the bandwidth. Okay. So here's an example that you might want to look at. It's pretty simple, right? So you've got, in this scenario, I've given you bandwidth as well as weight, right? So you've got weight as well. So W is weight, AB is available bandwidth. So when there's a tunnel requirement from PE1 to PE2, and the bandwidth requirement is 4, what are my options? Well, and we're assuming 10. So if you look at it, it's like 1, 2, 3, 4, right? But what's the total weight here? So if I want to go from this to this device, like obviously if you go down, the optimal looking at this, right? Hold on, sorry, I think you can start.
Yeah,
No.
so one of the question I have is
Yeah,
I
Ali, I
think
see it. Yeah, I see it.
yeah,
Increase the volume
RSVP I
here.
think permanently reserve the bandwidth, and even the application is not running, this is already reserved. It's not going to be utilized for other services.
Correct. So yes, let me finish this and I'll come back to that. Is that okay, Ali?
Okay, thanks. Thank
Yeah,
you.
yeah, of course. So in this scenario, like if you look at the path from PE1 to PE2, I'm looking at the first one here, right? The first, sorry, the first. Where's the, why did I not use, oh, it's not my computer, that's why. So we're looking at the first condition here, okay? So we're going from PE1 to PE2, right? And our bandwidth requirement is 4 megabits per second. So this is the most optimal path because it's the shortest one. However, look at the available bandwidth here. It's 3. And I need 4. So by default, I'm like, I can't take this path. The other option is 1, 2, like this path. So it's 1 hop, 2 hop, 3 hop, 4 hop, 1 hop, 2 hop, 3 or 4. So the both of the top ones are the same. So how do I decide which one is better? Well, we have to take weight into account as well. And how it's done is you add all these values. So weight 1, 2, 3, 4 versus 1, 5, 6, and 7. So 4 versus 7, lower weight is preferred. So in that scenario, it's like, yeah, I'm going to take this path because that's what I need. Obviously, I'm going to check the bandwidth because 10, everything available is 10. So I will take 10 minus 4. The new available bandwidth would be 6 here, 6, 6, 6, 6. The top one is still 10. So this is how it does, the combination of weight, bandwidth, and finding the optimal path. Now, Ali was asking, the problem with RSVP tunnel engineering is when you put the bandwidth, it permanently reserves the bandwidth and not available for our services. Yes, that's true, right? Once you do that and you've taken it out, that means this is yours. And the idea is you can use it for voice traffic. And you do not want to affect voice traffic because unlike other traffic, voice is very, it gets affected very quickly. Little bit of jitter, congestion, voice traffic is gone, right? Where other services might be a little bit okay, right? So you want to put your important traffic here. So I'd say ISPs will probably need to put their management traffic within the environment so the management is never affected. If you're running 911 services, critical services, something like that, go on this. But yes, does that answer your question?
Yeah, absolutely correct. But I think in the modern, like the network technologies, there are too many application and services
Correct.
that requires reservations, and it should be dynamic. Whenever the traffic is there, it is there. When traffic is no longer there, it should be removed, right?
So that's what the reserve is, right? So when you make the reservation from source to destination, it reserves it. And then when the transmission is done, it breaks the tunnel and makes the available bandwidth again. But you're saying if there's someone who's just doing regular traffic, yes, then that's a problem. But
Yeah, I mean to say summary is it should be dynamic, right? It should not be static. Means RSVP is very much static.
yeah, but
However, the modern need is like dynamic, based on
yeah.
demand, right?
So if yeah, I'm pretty sure as more processing is available. Actually, you know what? So yeah, I remember the discussion I had with this. So what Ali is saying, class here, is this is a static configuration. Once you put in, then you have to go manually. There's no dynamic way around it. Once you reserve the bandwidth, that's for you. When I was having a discussion with, I think it was Cisco or Juniper, they said that the cost of bandwidth and is going down so quickly that you can just keep adding bandwidth in the future. And generally speaking, with SD-WAN kicking in, this is not going to be a problem. You'll only have very specific application running on MPLS VPN. And by definition of how cost is, you will not run into these problems in the future. Okay. So it's just cheaper to do it this way for now. Yeah, we can optimize it, but when you optimize it, the CPU cycle, everything it takes is just not worth it. Just throw more bandwidth at it, as they call it, in the long run. Yeah. Okay. We can have further discussion around it once I'm done with the class, I guess. Yeah. All right. So there are the link attributes we talked about earlier. I'm like there are also something called link attributes. So here's what the link attributes are. I think I talked about this last time in the class. It's used to provide additional constraints, meaning it's a value, it's a 32-bit value, 0 and 1, and each value gives you some specific information. So over here is an example, like these are your bits, 32 bits. One of them, the last bit is 0. If you put that last bit as 0, it means it's a wireless connection. But if you make it 1, it means it's a landline physical connection. Okay. If you put the last bit as 0, it means it's a low delay. If you make it 1, that's high delay. These are different configuration you can put in there. All right. So if you want, it's like, hey, is this a private Canadian connection or is this a non-Canadian connection? So 0 and 1. So these are different attributes you can configure end to end depending on every single link. So if you think about a big company that has hundreds of links, this is complex, right? You got to put all the information in. And this is one time you configure, it's not dynamic. And anytime it changes, you have to go in and do it again. But the reason it's done is when you're sending traffic from one side to the other, and let's say one of your link attribute is like, hey, I do not want to use wireless link. I only want to use landline. So when you reserve the bandwidth from one side to the other, whatever you do, you put a value that you want to see this as 1. Okay, so the last bit has to be 1. And then it reserves a path based on that information. He's like, okay, I got to take a path that's only landline, right? And this is how it do it. If it doesn't find anything, it'll be like, sorry, I can't do it, right? That's a bad design. You as an engineer, so in the world of network engineering, you have, you've got your edge engineers, you've got your core engineers. So this is hardcore core engineering, meaning you need to understand end to end. You got to be, how does my entire network looks like? How do I have what? And you design this. Okay. Does this sort of kind of make sense? Right. I have no idea. I can't see your faces today, which I usually love to see. So just go ahead and put that information in the chat if you have questions. All right. And this is what I was referring to. Okay. Oh, affinity bit. I haven't talked about it yet. Okay. Um, okay. So I forgot about affinity bit and a mask. So, okay. Suppose all secure links have second last attribute bit set to 1 and you want to build a secure MPLS tunnel, meaning right here. So let's say the second last bit is encryption or secure, whatever term secure means. Okay. And your condition is, so you want to send traffic from one side to the other, and you want to make sure I have to use the secure link. Like it has to be the secure bit. So the second last bit is, like whatever, 32 bits, and the last one is 1. So in this scenario, how are you going to match it? So the way you match it, and this is the affinity bit we send, where we'll send a value of 0x02, which you convert into binary. You will see it's all zeros, except the last bit is, sorry, second last bit is 1. Okay, and the next one is 0. And the mask is 0 times 02. What it means when you send a mask is, so if I, hold on, I'll convert it. Are you guys good with conversions or, uh-oh, how do you read me? Uh, Discard. Okay. Here. Actually, I'll do one thing. I'll convert this into. This is not my computer, guys, so it's a little difficult. So I believe this will convert into 1, 2, 3, 4, 5, whatever it is, 1, 0. Let's say this is what it is, right? This is C, X. Okay. Is this, you guys can see it, right? So when you send this value in of 0020 and the mask of this, what it's saying is anywhere there's a 0 in the mask is like, I don't care about those bits. I don't care if it's a 1 or a 0. Ignore it. But wherever there's a 1, he's like, this is the value I have to match. So by putting a 1 here, the affinity bit is like when I'm making a tunnel across, because I sent it with the mask, this has to match. Versus if you do not send the mask, what's the difference? Yes. Okay, hold on. You know what? I'm going to open a browser so I can do this conversion for you guys. Give me 1 second. Online class sucks. Actually, I'm going to do it in front of you. Okay, that's exactly what I showed you guys. Kind of. Did somebody send me a message? Nothing here. All right. Now, I'm going to take this value and see what this converts into. Because technically what we're showing here is this is a tunnel request coming in the PE, and these are the different links showing different value. Thank you. I'm doing it here because I'm just doing it slowly. Where did it go? Here. Okay. Four, four. Okay. So the first one that I got is, look at this one. Trying to make it as pretty as I can. Uh, wait, this is the two. Now the next one I had to do was, geez, I can't see crap. Uh, I went on the long slide. That's why I can't see crap. So next one is 0x 10. I know some of you have given me the answer. I'm just doing it so everybody can see it how I'm doing it. Oh, it's even bigger. All right. All right. So basically, and then I'm gonna do 0, 2, which is the same as this one. Oh, geez. Stupid Windows, whatever the new version they have, this just broke all my shortcuts. And then the third one is 0xa in Word. And oh, that's what it is? Okay. 0xa. All right. So let's minimize this. Okay. So if you look here, and I'm going to make it if 4. All right. A little bit of gap here. So you guys can see it. Let me see what I missed. Yeah, okay. Did I make any mistakes? I hope not. Okay. So now this is a request coming in. This is a request I'm sending. It's like, hey, I need 1, 0. I want to make sure one is a match. Like, I don't care about the entire bit set, but I want to make sure the second last bit is one. So if you take the first link, which is 0 times 10, this is the value it creates. Excuse me. Does the one match here? No. Just looking at this one, he's like, hey, this is not a one. So this will not match. He's like, yeah, I can't make a tunnel here. What about the second one? He's like, oh yeah. He's like, yeah, one matches. I can make a tunnel here. What about the third one? Yes, it matches. So I can make a tunnel here, right? So what this affinity bit is saying is ignore everything else. Sorry, the mask, just match the one. So in this scenario, both of them were one. So it's like these two are possible tunnel options. And it'll do the same calculation. Let me see how much bandwidth it is. What else matches? And boom, I can use either one. Okay. So this is the condition for the tunnel one that came in. Now, tunnel two request, there's no mask. Right? Copy. Geez. Stupid Windows. So this is tunnel one. Right. For tunnel two, E2. That's a good movie. Right? I did not send a mask. What that means is I have to match the exact thing for the whole end to end. It has to match exactly. So in this scenario, the only thing that matches is this one. So link number 2, and this is exactly what I said, only this link will be considered. Does this make sense to you guys? Sort of, kind of? Right? I just wanted to explain all these bits is what we configure and it means something. And when the data is being sent across, you match these values. So if you send a mask, you're matching specific values. But if you do not send a mask, everything has to match. Yep. Okay. How do you configure this? Here you go. MPLS traffic attribute flags. You put the value in, and then under the tunnel, you configure it. Affinity bit width. Okay. Pretty simple. So look at this example, right? Okay, look at this example. I will let you guys do some math here. So you've got this wonderful configuration here, and you need to send traffic from tunnel 1 across tunnel 2 and tunnel 3. So what would be the path? All right. Look at the first value. It's saying affinity bits 000, meaning I'm sending you zeros, and the mask is 0. So the first device is saying I don't care about any of the affinity bits, right? Because if I send a mask of a 1 value, 00 is all zeros. It's like just send the traffic across. So I have to look at what is my bandwidth request for. Based on that, I do the calculation of what's my shortest and the least weight path. So PE1 to R7 to PE2. Can I take that? Yes. Right? Bandwidth 10, so I don't have a problem here. Weight is 5. All right. What about the one in the middle? 1, 2, 3, 4. So that weight is 4. I'm talking about this one, right? Okay, so this is better than 5, so this is a better path. And then finally, I'll calculate this 4, 5, 6, 7. So probably PE1 will go from here to PE2. That's my path. And now, because I use 4 megabits, all the new available bandwidth between these devices would be 6. Tunnel number 2, PE1 to PE2, bandwidth requirement is 7. Just because it's 7, I know I can't send anything in the middle because I only have 6 available. So that's out. Okay, so the option is top or bottom. Now, I'm sending some affinity bits. Ooh, 002. And I'm sending a mask of this one. So if I have my notepad still open, I'll bring it here. Right. I don't have to show you guys how you can do the conversion. Right. So for tunnel number 2 in this scenario, I'm sending O2, but my affinity bit is times 3. Right. So that means it is 1, 1. So what that means is I need to send the traffic all the way across, but the last 2 bits have to be 1, 0. All right. So to have 1, 0, what's the other option? Uh, so 1, 0 means any last 2 bits. So let's do it. So I know anything with 0, 2 is 1, 0. So this is 1, 0. This is 1, 0. For 0, 6, I don't know. We have to calculate. So did I close the 0, 6? Word. It is 1, 0. Okay, so in this scenario, this path is still valid. Okay, oh, sorry, not the wrong one. Right. What about the top path? I can't take the middle path because the bandwidth is not available. So I gotta check this one. So 02 is available, 03, yeah, it should be. Right, so the bottom path is also feasible. I can go via this way. However, my weight is 5. Over here, the weight is higher, so I'll probably go this way. RPE1 to R7 for this one, for the second request. Okay. And the weight, the new available bandwidth would be 10 minus 7, 3 on both sides. And the last one, well, I don't have an option here. I can't take this one. I don't have an option here because like I need 7. So it has to be on top. However, my request is 02, mask is 02, meaning I need to make sure that the last 2 bits are 1, 0. Okay. So this is 1, 0, 1, 0, and 6 is, let's go back, 1, 0 as well. Sorry. 6 is 1, 0 as well. So in this scenario, I will take the path that's on the top. Actually, he did it differently. Oh, 5. Okay. Hold on, why? I gotta check one thing. Is a higher rate preferred or lower rate preferred? I think it's lower rate that's preferred. Why would he take? Anyone remembers? Only the second to the last bit needs to match. For which one for or which one are you talking about?
Yeah, so the mask says 0x02, right? So
Okay, okay,
the
yes.
binary is 010.
Yeah, I got it. Yeah, so it has to be one that's the only one he has to make. Okay, I made the mistake there. Sorry about that. Let me go back, make sure I'm right. So mass 03 is 1, 1. That means 1, 0 has to match. This should match. Okay, but this one, 6, 1 is 1, 0 as well. But in this one, I'm sending mask 0, 0, so I have to send only the one bit has to match. Okay. I did something wrong. I don't know what it is. Let me think. I can't remember. I think I totally believe lower weight is preferred. So why did we take? Anyway, you guys can do the math here and figure it out. I'll draw the whole table in terms of binary and figure it out. Okay. So for this one, I'm sending this one, and this is my mask. So it has to be 1, 0. Okay. 1, 0, 3. 1, 0, 3. Oh, okay. I know the mistake I made, guys. Sorry about that. Okay, I can explain it to you right here. Sorry, I know what I did. Okay, I'll delete this. So for tunnel number 2, my request is this, right? This is the affinity build, this is the mask. Now, if you look here, I have 3 different values. I have this one for all the tunnels, right? I have this value, I have this value, and the last one is 6. I think that's the only one that's different. 0, 6, and this is 0, 6, right? And there's also 0, 3. Okay, when you convert 0, 6 into, right, it becomes 1, 1, 0. All right. Okay. Okay. So these are the different tunnel options we have. What do I have to match? I have to match that I'm getting 1, 0 at the end, right? So anything that has 3 in there is not going to match. So this path from P2 to R7, this will not work because I have 1, 0, 1, 1, not 1, 0. So hence why this path is the only one I would take. That's what we've shown. And for the last one, the request that's coming in is 2 and 2, meaning I'm saying make 1, 0 as the only option. And we know that 0, 2 and 0, 3 both have, sorry, only the one matches. So in this scenario, this will go here. Sorry, I made a little mistake. Did that make sense to you guys? I have no idea how your faces are looking or what you're saying, but hopefully when I explain that, okay, somebody's raising their hand. I hate. Yes, go ahead, Pod.
So I have a question about the bandwidth, right? So
Yep.
I'm a bit confused how it works. So like
Okay.
tunnel two is choosing to go upwards. That has more weight, right?
Yes, but that's the only option. So the weight is utilized when you have multiple paths.
Okay.
So for tunnel number 2, you cannot go from this way because the bandwidth is not available. You can't go through R7 because the path request doesn't match. It's 1, 1, not 1, 0. So your only option is this way. So in this scenario, if you had another option, you would calculate the weight, but it's like this is the only option you have, so you have to go this way.
Okay. So yes, so that then my question is like, how do we know when the bandwidth is available?
So if this was the only option,
Yeah.
right, I would check the bandwidth as well. And let's say right now it's all 10 megabits, so my request is 7, so I can use it.
Yeah.
But if there was not enough bandwidth, let's say it's only 4 left, then this tunnel request will be like, yeah, I can't make a tunnel. Sorry.
Okay. So
Okay,
by
it'll be like,
default,
nope. Yeah, sorry.
yeah. So by default, all links have 10 megabits.
You configure it. In this scenario here, like I've given you the example here, right? 10 megabits. Okay?
Mm, mm.
So whatever you configure. Yes,
Okay.
no? Anybody else? You can lower your hand. Okay. Before I jump into the next one, do you guys want to take a few minutes before I go further? We go into the constraint-based uh, SPF, which is shortest path first. Actually, I can go through it really quickly. You guys know how to calculate this, right? You guys, you've done OSPF, right? Constraint based. you take all the values, you put it in, and then you create a link path, a link state algorithm, right? Put the digest-store algorithm in there, and you make this information, and then you create a routing table, right? OSPF uses digest-stores, right? Okay, so in this scenario, right? Like, look at the routing table. Like, I have no idea what you guys are saying and stuff. Okay, you want a few minutes of break, 5 or 10 minutes? Yes or no? Yes. Okay. So let's take a few minutes. Let's start back in at 6:10. Okay. Break. We start back at 6:10. Okay. Come back. I'm gonna grab a glass of water and then we'll talk again. Okay. I'm gonna stop sharing for a minute and I'm gonna mute myself and pause. Amazing. Okay. Somebody's really good at that. All right. I got a question for you guys. Um, I need a new laptop, but like most of it is teaching and like paperwork, as I call it. But I don't want to change. Sorry, 1 second. Give me 1 second. Kids are home. Okay, I'm back. Sorry about that. Yeah, so I was leaning toward getting a Mac because just want something very slim that has long battery life and just functions properly. Anybody has any experience around that? Any laptop I looked at that function or was as close to a Mac is like super expensive. And any cheap one are like, they have a lifespan of 3, 4 years, but the battery is really, really crap. Plus, I forgot to tell you guys, I get a Mac has a special offer for teachers and students. So if you're buying a Mac, they give you like $200-300 off on the device. So it becomes even cheaper. Okay, I got one answer. There's That's what I've heard. Anybody who ever gets a Mac is like just never goes back to anything after. It just works so flawlessly. It's insane. Yeah, that's what I was thinking. Yeah. Actually, I was at Costco. I'm a big Costco person. And they have one, they bring, I think the color is not in demand. So they were like, it's like $200-300 off. I was like, I can't go wrong with that because they give you 3 months of return capability as well, right? So, all right, let's start. 6:10. We shouldn't be recording that, but that's all right. So constrained SPF, shortest path first. So link state algorithm, how does it work? Participating routers know to complete a topology of the area. So in this scenario, it's like,
Professor, we can't see your screen.
oh yeah, I didn't share my screen. Thank you. That would be very helpful. Can you see it now?
Yep, thank you.
Amazing. Okay. All right. So if you have a topology like this, A, B, C, D routers, right? Basically, you make a topology table. This is just like how OSPF calculates the best route, right? And you put it together and you're like, okay, I know how to go from one device to the other, right? And you find the infinity, it's like, okay, this is not an option. And that's how you actually calculate the destination. That's exactly what we were doing here earlier, right? So now going forward, how does it work? It used to determine a path for the tunnel. So it uses the same mechanism, right? To calculate, okay, when I'm going from, because it's destination based, when I'm going to a destination, I need to consider all the attributes as well. So it's like, okay, let me find out what's happening here. Used to determine path for a tunnel head end to the tunnel tail end, not every destination. So only the destination that is required. The SPF is computed based on the admin weight under the following constraint, available bandwidth of every link is selected path is greater or equal, meaning I have enough bandwidth that I need to send data across. Otherwise, it's pointless to calculate that. And then it checks the affinity bits. So if you're sending a mask, then it'll match the specific bits. If you're not sending a mask, then it'll find the whole thing. And based on that, it calculates a table, and then it forwards the data across, okay, when everything matches. If more than one path are available, choose the path with the following tiebreakers. Take the path with the maximum minimum available bandwidth, right? So highest number of bandwidth that's available. Okay. If all the bandwidths are same, well, what's the highest one that's available? Then take that one. If there is still a tie, take the path with the lowest hop count. If there's still a tie, take the path at random, then just pick one. Okay, and then generally does the thing. Usually the first one should be your tiebreaker, shouldn't go further down. All right. So in this scenario, look at all the values you have. So forget about the table down here, but look at the table. Look at this for now. Okay. So you're going from A. So link is described by admin weight and available bandwidth. Keeps track of path metric, the path and minimum available bandwidth. Determine the tunnel path from A to D with the requested bandwidth of 60 megabits per second. So from A, we have to go to D, right? So looking at this, there are different features. So the 3 is your weight, and this is your bandwidth that's available, right? So looking at this, right, the option we have is 1, 2, back. You can calculate all these options, right? The bandwidth, most of them are the same. I need 60, meaning C to D is not going to work. B to E is not going to work. Everything else is okay. Now I calculate the best weight. Okay, so what's the weight I need? The lowest one. So from here to 5, 7 plus 3, what is it? 10. So going from A, C, E to D is 10, right? Then going from A to B to D is 3 plus 3 is 6. So yeah, and that's it. I mean, that's the only option available. So the two paths available are this one and this one, and based on this, it'll take the top path just because it has less weight. That's it. Am I right? So A, B, D, yeah. I double check myself. A, C, D is not available because this is not enough bandwidth, right? And A, B, E, D wouldn't be available because 30 is not enough bandwidth. We need 60. Does that make sense, sort of, kind of, to you guys? All right. Because of the tables, it does look more complex, but when you get to when you understand, it's like, okay, this is just how you would drive. So this is your airport, right? And you have different modes of transportation. This is your, let's say this is the cost. So the highest cost is 407. You go from here. Sure. Right? You go from here. That's fine. Because you have luggage, you can't take this path because this is like a walking thing. You can't walk. You can't take this path because this is a walking thing as well. So you got to either drive, take Uber, whatever it is. And based on that, you're calculating different options. If Uber is $30 and a regular taxi is 50, what is your preference? Probably Uber, right? But there are needs where you would, if Uber is going to say, I'm going to get there in 10 minutes, but taxi is available right away, that might be a better option for you. That's all it is. All right. Look at this example. In this one, we need to use the tiebreaker. So what we're trying to do is same thing, right? We want to go from A to D, right? So, all right. So now, and the weight is, if I want to go A to D and I have 60, this path is, what is it? 3 plus 3, 6. 2 plus 5. Sorry. So A to C to D is 2 plus 1 is 3, and E to D is 6. So in this scenario, A, B, D is the same as A, C, E, and D. Okay. Now, what's the first one we take? The larger of the minimum bandwidth. So what's the minimum bandwidth across? This is 90, actually 70. Which one is this is 70, and from A to D is 90. So then I will take this path because this is better, right? This is 90 versus this is 70. So I have more minimum bandwidth available. That's what it means. Let's say the bandwidth were the same. What would be the next option? Minimum hops. 1, 2, 1, 2, 3. Okay. And if that was the same, then you just pick one. Got it? Okay. All right. So this is more again, I'm not going to go through it. You can calculate it. Basically, now I've actually given you the affinity bits, right? The attribute bits. I've given you different values, and I've given you determine the path from A to D with request bandwidth of 60 megabits per second. Okay. The complete path should also be within the Canadian boundary. The above condition means that the affinity bit is this is what I'm sending. All right. So mask of 0 times 4 means one of the particular bits has to be 0. Okay. Convert all of them, find the best one. I'm sure you can do it. All right. Yes. Like I showed you how to convert these into binary and then match the bit that we want to match. Because all bits are 0, this is saying I think the value of 4 is 1. It's 4. So it's the third bit that's 1. Sorry, third bit is 0. So we're saying in all of these, the third bit needs to be 0, and you find that one, do the calculation, then you can find the destination to A to D. All right? Are we okay with that? Again, this one is a little bit different. In this one, I'm saying node 1 to node 4, 1 to 4, right? The bandwidth requirement is 4 megabits per second. This is the affinity bit I'm sending and the mask. You guys can do this one as well. You want to try? You guys want to try for a bit? You want me to do one of this one or the one of the bottom one? I'll let you take a. Where's my chat? Sorry, I can't see it. That's why I'm like, where did the chat go? Okay. You're not sharing. Okay. Yeah. Anybody has any requests? Do you want me to do one example? I can. Just say yes, no, maybe. Yes, please. Okay, let's do one. All right. I'll do. Let's do this one. This is a better diagram of this. So what I'll do is like this is how I. You guys need to practice how to convert um, hexadecimal into binary. So I've got. Okay, what's my request first? So my request is 000 and the mask is 0x4. Okay, so let's convert that. 000 is 0x. Convert. Copy. Okay. I'm gonna write it here. Okay, so this is my request. Now I'm gonna convert. So A to B is equal to 000, right? B to C. There's no B to C. Okay, so A to C, sorry. A to C is equal to, so it's 0x4 will be this. And then the next one is, actually, I don't have to convert all of them. What I'll do is I'll check the bandwidth. So my requirement of bandwidth is 60. So all of them are above that. So I'll have to convert all of them. It's fine. Then we'll go B to D, right? And that is 000. Okay. And then there is B to E, and that is 000 again. Oh, sorry, B to D 0, B to D. What did I do? Is yeah, B to D is this one, sorry. And B to E is 000. Okay, then you have C to D. which is 000. And then you have C to E, which is, that's all the same. And then you have E to D, which is 000. Okay. Right. Now, what am I sending you? I want to make sure that this bit is 0. Okay. So any path I request, the third bit needs to be 0. So looking at these, right, this is fine. This will not work. I'll put an X here. This will not work unless I made a mistake. Oh, E to D is, oh yeah, sorry. Thank you. This will not work, B to E. This will work, and this will not work, right? So these paths are out because I have to match this bit, right? And this one, these are the only one that are matching. So, okay, based on this, C, A to C, this path I can't take. B to D, this path I can't take. And, well, then the only option is A to B to E to D, right? A to B, B to E. Oh, that doesn't work either. No, B to E should work, but this is 0, 0, 0, 0. B to E is, I put it incorrectly. Sorry, guys. Yeah. See, that's why I need a whiteboard. This is a lot easier for me to write. And then E to D is this one. So the path is A to B to E to D. If my calculation is right. I'll paste it in the chat so you guys can use it later if you want. Yeah, just be ready, practice, because you're gonna have some questions on this, and you'll have to do conversions. Okay? Make sense? Yes, no, maybe? Right? The easy thing here is because all the bandwidth is above 60, so it was easier, but otherwise you'll have to calculate the bandwidth too. And I don't have to worry about the weight because that's the only option I can go. Now, doing this one would be the same. I would convert this into binary, make sure what am I sending, affinity BASC, this value needs to match, and just match it. Okay, you can do this. Seems more complex than it is. You're okay with this one? All right. So remember slide 22. Maybe we'll come back to a few guys once we're done. Okay. How do you create an explicit path, IP explicit path name, enable, disable, right? And then you can put path creation options there as well. So what this means, a tunnel can be explicitly created. So if I'm creating, let's say I'm creating service for 911 police services, then I'll be like, this is the path I want to take, and I'll put that information in, and that's the path it will always take. So you can do that as well without using the calculation. Okay. Set up a path, a tunnel path from A to D with required bandwidth of 60 megabits per second. Prefer tunnel path ABD, then ACED. If the dynamic path computed by CSPC algorithm is not feasible, then adopt the explicit path. Okay. Okay. So what we're saying here is I need to go from A to D, right? And my requirement is 60 megabits per second. That's all I'm saying, right? And then what I've said is the preference, there are two preferences. I should be able to go from A to B to D. The other is A, C, E, and D, right? So it's like this is the first preference, this is the second preference. I did not put A, C, D. Okay. If the dynamic path is not feasible, then adopt the explicit path. So if that is not feasible, then whatever I configure explicitly, use that one. So I'm like, try to use this feature first. Otherwise, put that information in. So how do you configure this specific value? Here you go, right? Look at the configuration on the tunnel, MPLS path option 10, path option 20, right? So first, do it dynamically. Use your CSF 20 explicit name path one. This is what I'm calling you. It's like now I'm telling you, hey, go here, then there. So 1.2, 1.4. Where's 1.2? Where's 1.4? Right here. It's like send this traffic to B and then B to D. This is what the IPs are. 68.1.2, 68.1.4. 68.1.2, 68.1.4. Okay. The second one is A to C to D to E. So I'll have 1.3, 1.5, and 1.3, then 1.5, and then 1.4. So 1.3, 1.5, and then 1.4. All right. Tunnel engineering is complex, guys. So you're looking at this, you're probably like, what the hell is going on? Yeah, it is, but it's just an option to get away from further from fishtail. Once it's configured, it just works. Okay, so remember that. So now we're talking about the reservation protocol, RSVP dash tunnel engineering, right? So this is the signal protocol for setup. So we talked about how it works, what's happening. Now we're talking about how actually the tunnel works, right? So this is the label request that we talked about. So when the tunnel is being formed, he sends the information. He's like, hey, I'm the end router, right? This is my bandwidth. Keep sending it into the destination. This is the available bandwidth, right? And then he's like, okay, I'm going to reserve it, replies back. D sends an implicit null, meaning, yeah, C, when you send me the packet, remove the labels, I'll process it. C sends a label to B, and B sends a label to A. So now, anytime traffic is going forwarded, the MPLS tunnel, the MPLS labels are utilized to send device the packets forward. Okay. Make before break approach, meaning first off, you send the request, reserve it, and then before you tear anything down, right? Like you will, let me explain this a little bit better. All right. So if you have a tunnel up and running and you're sending the packets across, that's fine. Once you're done, it's done. But if you have another request come in for the same destination, right? Then you'll try to reserve a new tunnel. It won't be like, let me remove the old one and then create it. No, you try to create a new tunnel. And if that is fine, then it's good. You use it. Then you take the old one out. It's just how it's configured. Okay. And if you don't have enough bandwidth, you're like, sorry, I don't have it. I can't make it here. So the idea is you make another tunnel via another path if necessary, right? Direct traffic through the tunnel. Okay. So now you've made the tunnel across. How do you direct the traffic through it? You create a static route and put the tunnel number and name in there, and that's how it sends the traffic across. Right. So configure a static route on the tunnel head and use the TE tunnel as the outgoing interfaces. So you have a tunnel across, let's say it's A, B, C, D, whatever it is, right? Or A, C, E. For this router, for the traffic to go in, you just point towards the name tunnel one, and it will take whatever is configured. IP static route, S1, sorry, not S1, this one, this one, this one. So that's the physical interface. You put it here. IP route, whatever, in tunnel one. And then it sends all the traffic destined to 10 network via tunnel one. And whatever parameters you have in the tunnel one, it'll utilize it, just use that destination. Oh, okay. Direct traffic through the tunnel. So you also have a policy option where you can create a policy, configured policy on incoming interface solely based on the destination IP. So you can do policy-based routing. It's like, hey, I've got data traffic, send it from the tunnel that's up there. I've got voice traffic, send it through the bottom one, right? So you have two different tunnels to the destination, one top, one bottom. How do I make it work? This way. You match the IP address coming because you have to, or tags. You can match the IPs or you can match the QS parameters. And based on that, you set the tunnel interface to 0. Otherwise, take the regular one, or you don't even need to take the tunnel, whatever. It's used regular routing. I will only let you use the tunnel if it matches certain conditions. Okay, that's it. And in this one, the match IP address 101 is this IP. Okay? Voice gateway. I think Ali can probably this is something that's very common that's done, right? Hold on. Forgot how painfully long this is. Reoptimization. Okay, we're almost done. All right. So direct traffic through the tunnel. How does the router dynamically adopt the tunnel route to reach the tail end of the network behind the line? Okay. I forgot what this is. Give me a second. Let me remember. Oh, okay. Yeah. So, if you remember the configuration that we did, let's say you have a path looking at this hop, right, from R1 all the way to here. So how does the traffic knows that, hey, I gotta send this traffic all the way across? Because when you create a tunnel, right? When you put this option in, you don't advertise it to everyone, right? You just have labels. So when you put the auto route by default, that's how you utilize it. It's like, hey, how do I send the traffic from here all the way to the end? Just create the command auto route announce. So that way you announce it across, like, hey, here you go. This is the tunnel I'm going to send it out to. Yeah. I have done a lot of work over the years. Um, And generally, when it came to tunnel and tunnel engineering, it was always configured, and I just had to use them or just had to understand them. Sometimes you just needed to modify them. Generally, you do not configure these. You have to be at a very senior level to work on tunnel engineering. It's like 10, 20 years of work. So you're an architect at that time when you're doing this. For most of you guys, this is to understand the technology is there. It can do cool stuff and most of the time it's used by service provider. Anybody here has any background information on this can build on it? Okay. So when you put the auto route configuration in there, then what it does is basically it does the same digest-throw algorithm, but it includes the tunnel interfaces. So when you're calculating your routing table, the next stop interface is actually the name of the tunnel, right? Because the tunnel, if you remember, let's go back here. Let me go back here. If you look at here, tunnel 0 can have 3 different paths. So it can take it dynamically, or it can be the path 1 or path 2. So it will decide. He's like, that's not my the routing table. Like, it's not my problem how the tunnel is created. I just know I need to push the traffic to tunnel 0, and it might be dynamic, or it might be explicit, path 1 or path 2, right? It does that calculation separately. It doesn't have to bother the routing table, like right here. Yeah. I think so, Ali. I'm not that I can't answer that well. I'll have to do some research. So Ali was asking if these tunnels are overlay. I think they are because they use MPLS. Okay. And that's how we make them fast. Oh, you can also put a tunnel priority in. So tunnel priority is you can preempt a lower priority tunnel, meaning if you've got again, right, you're competing for a tunnel bandwidth, then you have a priority in there, and the priority will break. It's like, okay, this is a priority traffic. Example, if you have multiple voice traffic going through a tunnel, or through a link, and it's 911, so you're like, you know what? I don't care what it is. The 911 will always be there, so it will break it. Look at the example here. You're going from A to D or B to D, right? So you've got tunnel 1, bandwidth is 80. Priority 7. This is 100 megs, right? Sorry, let me rephrase that. So the bandwidth right now is 100 megabits per second. Tunnel 1 request come in. Is like, hey, I need 80 megabits per second. My priority is 7. Fine. Tunnel 1 established. Use 80 out of the 100, meaning 20 is left. the priority value is less than 7. It's like, okay. Tunnel 2 comes in, is like, hey, I need 50 megabits per second, but my priority is 5. When this happens, tunnel 1 would be taken down. Let me see. Tunnel 1 is torn down and tunnel 2 established, meaning, oh, I've got someone who is more important or more, I will disconnect everything to serve him. And this is what you use in a lot of conditions. So if you have multiple voice traffic, customer A, B, C, D, you can utilize that. And this is the Netflix, the Net Neutrality Act came in. This is what they were talking about. It's like, hey, if we have if I've got Disney and Netflix, I'll give a higher priority to Disney. So people who are in my network, when they watch Disney, the quality is awesome all the time. And when they're watching Netflix, if it's congestion, they'll be like, yeah, you're not getting the priority. I'm gonna dump you down and down. Disney will work way better than Netflix, right? You'll get like I can limit it. It's like, hey, you're only gonna get 1080p, not never a 4K on Netflix. This was the bigger problem because on the network side, you can actually absolutely do this. The idea behind this was to serve important services. So when you have your fire, ambulance, police alerts, because they also use IP networks, they should have a priority one. Doesn't matter what services you're running, life above everything else. Defense, security, tunnel priority number one, right? Does that make sense to you guys? The funny story is, like, this is the last topic I always teach, and I always forget how it works. And it is pretty painful. Holding and set up tunnel priority. So how do you do that? Right here. This is the put the configuration in. You guys have ChatGPT, you can figure this out really, really quickly as well. Okay, so once you put that in, it'll work for you. Re-optimization, when a better path is available for tunnel established, the old tunnel is torn down, meaning all of a sudden bandwidth is available, or some reserve bandwidth all of a sudden is available, or manually you want to override something, then old tunnel is like, oh, stop it. Let me create a new tunnel and get it up and running. Okay. Periodic or re-optimization is around default timer is 1 hour. Generally, they put really higher. Personally, like when it comes to smaller, like Bell Rogers network, once a tunnel is made, it's like, hey, listen, let's not create overhead unless we really, really need to. Because even if it's not optimized, it works really well. Okay. Configuration, how you actually do this, right here. Awesome. And manual re-optimization, you can put this command in, and manually you can re-optimize it. Event-driven re-optimization, this is the command, and lockdown, tunnel MPLS traffic being path option. Lockdown option is, I don't remember what it is for personally. I will have to Google it. So just remember there is one option. And that should be everything. Yes. Oh boy. How are we doing? Any questions? This is a painful, painful topic, but it is actually very easy. Once you configure it, it just works, right? You just have to understand the concepts in here. Somebody had a hand raised? Anyone? Thought somebody had their hand raised. No? All right. So now, move this out. Let's discuss your exam. Okay. So I'm going to stop sharing for a second. Here we go. All right. And this is very counterintuitive. How do I stop sharing? Did I not stop sharing?
You're not sharing.
Okay. Good. But then where is my... Okay, here's the screen. Good. All right, give me a second. I want to make sure I finished everything. All the topics I've selected. All right. So we went through BGP. So your exam is going to be basically, the quiz part we did, but the exam is going to be out of your entire course combined. But the way I look at it, generally you'll have more on BGP, MPLS VPN, and tunnel engineering coming in, right? Those are the big, big things we've done. We took around 4 courses to do BGP, right? We understand large networks. We looked at how MPLS VPN works. That's really critical. And then we looked at tunnel engineering. Okay. So for your lab exam, probably gonna be it's a combination of three, which is you'll have BGP, you'll have MPLS VPN, and you'll have tunnel engineering. I am trying to finalize the exam for you guys. I haven't decided yet, but it could be an example would be you'll have to set up multi-ISP BGP network. Okay. And then you'll have specific configuration requirements using various attributes to accomplish few tasks. Meaning, hey, if for this network, use local preference. For this network, send AS prepend. Send these community outs to achieve something and show me how it's done, right? So that would be more of your lab exam. You'll get a topology, you'll have to go in and you have to configure it. Practice well for it. You'll need some time, right? It's not going to be like I'm not going to throw like 100 routers at you. No, it will be like a core kind of development. So if remember how to be set up BGP, make sure you can ping everything, show the routing tables, right? Show how you've achieved different configuration. That's all it's going to be. The way you're going to be graded on it is you're going to finish the lab. The teaching assistants, the TAs, will be there, and they'll walk over to each of you and then ask you to show you your configuration. So when we do this exam, right? So there are two options. You can do all of this, then you can upload it, then we can manually change it. I prefer them sit down with you, just like, hey, how did you achieve this? Show me what you've done, and they'll ask you to maybe do a change. It's like, hey, can you achieve this change for me and show me how you can do it? They'll grade you based on that. Once you achieve all of it, perfect, right? You'll get your passing grades, and that's it. So when you come in next Wednesday, be prepared to stay a little bit longer, right? Because you'll start between 5 and 5:30. It'll probably take you an hour and a half to do the exam. Then the individuals will have to walk around and then grade you guys. As they do the grading, you guys are welcome to. They'll set up the rules, but you can go out and come back because you don't want you to just sit there and wait for that long, right? You will have to bring your own computers. No, you don't get cheat sheets, unfortunately, my friend. Because when you're working on Cisco router, all the configuration is there. You do a question mark, it gives you all the options. Okay. So as long as you know a little bit of that, you will be okay. Okay, so that would be your example. The other option that I'm thinking is maybe make an MPLS VPN kind of network, give me some solution there. The other option is develop a core, set up tunnel engineering. So it'll be very scenario based. Okay, everything that you've seen and then before, basically out of your lab, right? You will have to, so the way we judge people is basically on time management. So you will have enough time, but not a lot of time. So just practice doing it right. Okay, and make sure you can get it up and running. You might not be able to achieve a lot of tasks. That's fine. As long as you finish most of it, I'm okay with it. That's how I'll grade you. Is like, hey, he got 100%, somebody got 90, somebody got 80, is based on what you accomplish. Does that make sense to you guys see some any command references? No. Will you provide practice question for the quiz? Um, I'm telling you those right now. So for the exam, so this was for the lab. Okay, so you'll be ready for the lab and you can work on it. Now, for the exam, hold on one second. Got so much junk here. I need a personal secretary now. My life is getting so busy. It's not that the life is busy. It's like I have to jump from one thing to the other and it just becomes a little ridiculous. Let me check something out. Can you share the answers for the quiz? Maybe. I'll look into it. Usually the reason we don't share, you cannot check your paper on the quiz, Mara, but I can double check it for you if you want. Any of you is not okay with it, just message me. I'll go through it again and I'll can give you a generic feedback. Just email me and I can give you feedback around what I found was incorrect or not. Generally, most of you did okay. The mistakes I found was when I said just show me the routing table, not the BGP routes. You actually put the BGP routes in there. And a lot of you had a mistake when you built the BGP route, you added your own AS number in there. So, if I asked you to show a router with the AS10 in the AS path, a lot of you added AS10. Plus, a lot of you were not able to compute the redundancy route, which is okay. Right. So the total marks were supposed to be out of 30, but the highest were 25. So I give everybody marks out of 25. So if you got 25, you're 100%. Okay. Anybody has any questions? Hold on. Generally, the reason I don't share the quiz back and forth is we utilize because there's only a certain amount of questions I can create, and we have to go back and utilize some of them questions again. With all the wonderful resources you have, everything is online, and then it becomes very, very difficult and complicated for us to um, quiz you. That's why I reduce the marks on the quiz and increase them on the lab because you got to sit there and do the work, right? To me, you passing the lab is one of the most important things. I really don't care about quiz in the final exam in a sense. As long as you pass your lab, that proves to me that you know what you're doing. Please be mindful that I'm actually making newer exams and newer labs. So if any of you are like, oh, I found this at the online and stuff, it's fine for practice, but don't expect it to be exactly the same this time. Okay? Right. I can just message me. I'll see if I can grab your exam paper on Monday, or I can give you feedback on what's wrong or what was correct. Most of you did a good job. It's practice, right? Okay. Any questions on that on the quiz slash? Yeah, I said that I wouldn't give you T in the final exam. I changed my mind. Right. If I give you tunnel engineering, it'll be very basic. So yeah, you gotta study it. Plus, I gave you one class off, so make sure you do all the exams. Yes, Kimia. I apologize if I'm not pronouncing your names right.
Hi, no, it's okay. Kimia. Yeah, you
Okay.
said it right.
Yeah.
Sorry, so if I understood correctly, you won't be uploading any samples for quiz?
I can, but I will discuss the exam. Like right now, I'll tell you the kind of questions, and I can put the examples online as well. Okay?
Okay, I
Um,
would be grateful.
yeah. I haven't. So this weekend, I'll probably finalize the exam and everything, and then generally the way I do it. Okay. So you'll have one question on MPLS VPN. What will be there? Um, I will give you a condition or a network diagram, and then ask you to achieve a certain solution for the customer, right? That's what I do with MPLS VPN, right? I'm not, so again, you got to put the level of configuration, but I don't really check the syntax. As long as I understand what you're trying to show me, I follow it, right? So if you put the syntax that's incorrect, right? Like say you instead of putting IP route source destination, and you put hey route traffic from this to this, I'm okay with that. I don't, but I want to make sure that the concept is correct, right? So same thing I will do for your final exam. I'll go through, okay, what have you done? What is there? So you'll have a question on MPLS VPN. You'll have a question on BGP, a bigger service provider network, right? It's like, hey, here's a big network. How are we gonna do something with it? You might get, I might give you an example would be like, here is a routing updates coming. You're a router, okay? And you're running BGP, OSPF, and here are the different updates coming in. This is your routing table. Process it and show me what your output looks like. Okay. And then I'd be like, okay, once you process and update it, what are you gonna do next? Are you gonna advertise those routes out, or what's the next process? Right? It's a theoretical exam, so that would be a question. The other question I would give is again, I talked about the MPLS VPN. I can give you some question around route reflectors. Saying it's like, hey, I just sent this route out. What's gonna happen next? What do you do now? Right? So it's more around, okay, this route went here, a route reflector will do this, forward it here, or what takes place next. Okay. Um, and then I'll ask you some question on tunnel engineering. It won't be tunnel engineering, like basically what I taught you here, right? I'm like, here's different. What would I ask you? Internal engineering, like I'm not going to ask you configuration internal engineering, but I'm going to like, here's the network topology. Here's the parameters. Show me how it will work, or tell me how it's going to process the path across, right? So that's it. And BGP, everything I taught you guys, right? In BGP, it's like, hey, this is a route that's coming in because it's a service provider network. Here are the communities. What is advertised forward, right? Um, my plan is to give you between 3 and 4 questions, and whatever they are between these 5, 6 topics I've talked about is what you're gonna get. That's it. Okay. I'd love to give you some more sample questions, but the examples I have in my slides and stuff, utilize those. Like I'm not gonna throw anything out. Most of the stuff is in the slides. I'm gonna probably modify it, give you a little more complexity, and then ask you to solve it. Okay. Does that help? Yeah. Okay. Hold on, I've got a lot of questions here. Like, okay, hold on. So I don't know. Do we get cheat sheets? No. Any command reference? No. I'm not being rude. Just it makes sense if I give it to you. And the lab exam, you don't need it in the exam. No. Even if I give you, you won't have time. Well, it can be have. Okay. Quiz question and solution. I talked about that. I think I'm sorry, I'm going backwards. So let me go down. Somebody who's crying, I'm sorry about that. There, you're gonna be okay. When will the exam start on the 23rd? So, 23rd. Oh, okay. So that's the Monday. I will be there between 5 and 5:15. I want to be there earlier, and then we can start at 5:30 tentatively. Okay. If everybody's there ready to go, I'll give you the exam earlier. Anybody who comes late, they'll get the extra time. It's fine. As long as most of you are there, unless something takes place, I get stuck. My idea is to each exam question will be like 15 or 20 minutes total. So you'll have around an hour and a half, or I think 90 minutes. Um, Maybe 2 hours. I find like, so my experience with giving you more time is you just write more junk. I just want to see answers. But don't write stories and stuff. There were some people who did write stories in the midterm too, and I'm like, I don't know that's not what I was asking for, right? Just show me what is the problem, how are you going to solve it in a certain way. Um, I'm going to use Ali as an example. I asked him to show something in a certain way, and he did it the other way. I'm like, okay, I know you didn't do it right, but it makes sense. What he did is correct. So I'm like, okay, I'll give you grades for it. I did deduct some marks for him because you got to read instructions. Part of doing a task is to understand what the instructions are. But it wasn't like it. I wasn't like, oh, I'm going to give you 0 marks. Okay. All right. So route controls include an exam. What do you mean by route control? Route control. I think the first class was redistribution and stuff. So I've not really focused on that. I've looked more into BGP, MPLS VPN, and tunnel engineering, really. Okay. And route manipulation. Should we focus more on understanding concept, configuration, reviewing past lab? I would say past labs and examples of what I give, right? It'll be a very conceptual exam. I'm not asking you to write a theory for me. Here's a topology. This is what I need you to do it. Here is what's coming in. What's the process of how it works? So really how things work is what I'm asking you to do, right? I don't think you need to memorize anything, right? Just understand what it is. You've done enough labs. Go through your labs, understand if you did it well, right? If you know how you did the configuration, just follow the basic idea, and that's it. When will the exam start? I said it's around 5:30. How long would the exam be? Approximately, yeah. Yeah, lecture 1 and 2 are basics. I don't think I'll include anything from them. I've already tested you in the quiz for it. So don't worry about it too much. But those are, foundation of how routing and stuff works, so do understand it. I'm not gonna give you a question on route redistribution and avoiding the loops again. Okay? Yes, all of tunnel engineering. I do not know which one. If you think about it, you only have like 3 topics. You have tunnel engineering, you have MPLS VPN, and BGP. I know it's a lot. Anything else, guys? Okay. Again, I think go backwards. Do the MPLS VPN lab properly, do the tunnel engineering lab properly, and do your BGP lab properly. If you understand those, if I had to re-practice, go through the slides, right? Read them, not memorize them, understand all the concepts. Go through the labs, and then you should be good. You should be prepared after that. Okay. Especially so, just remember if you can't configure BGP today, if you can't make a BGP table and have all those neighbors, that would be a very bad sign. Because BGP, without it, I don't think anything else will work. Okay? You gotta be very sure of how that works. All right, if that is everything, then we are good. I'll stick around and we can discuss something else if you want, but I don't have anything else to share. I'll try to see. I can't put examples of questions out there because that's like literally exam questions. This is all I'm going to tell you for the final exam. Be prepared, bring your paper, pencil, water. You won't be allowed any electronics on top of your desk. I trust you guys to do the right thing. Right? I've said this all this time. I'm not here to fail you. Right? That's not the purpose. I want to make sure you understand. But if you don't write anything and you just struggle with the lab in the final, that's just a big red flag for me. Okay? So spend some time. You have enough time between now and Monday. If you study, I'd say like 3 to 4 hours each day, you should be okay. I don't know what your other topic is though, so you have to spend time there too. You guys have my number. Just try not to bombard me all the time. But if you have urgent question and stuff, just text me or message me, usually, or email me. Email might be slower. Just I'll get back to you via text message or LinkedIn a lot quicker. It's just I'm teaching so many different things, so many different mailboxes. I am drowning to manage all the mailboxes and messages. So it's become really difficult for me this year. Okay. Okay. Should we stop the recording? I have no idea how to do that. Are we still recording?